That goodies. Y'all don't get too crazy at running out the doors, scrambling everywhere. Right.
And if you just pop into my lab, I put it right there.
No. Anybody got
No. I can't even answer the question.
Yeah. There's extra copies online and stuff, but your answers are probably halfway through. Wait, there's something here. No, that's true.
No, I'm there.
Check with these guys whenever they're working here. You can find it.
I've seen everything. I've seen one.
Yeah, I put a lot of.
Okay, if you have anything to turn in at all, it goes up in the folders over there on the chest. I think most of you saw it.
Emma did take my lab.
Did you find it?
Oh, it's okay.
Emma is staking her claim on that chair because that was Jack's chair, I guess. This morning, somebody else was in it and she was like, oh no, that's my chair. So, yeah, no, it's her
I
chair.
guess it's being passed down.
Yes, it has. It's like you inherit the chair.
Inherit? Yes.
Pretty much. Her brother sat there all last year. So, see, people are eating. Place.
And you're the one who died?
No, we just finished. Okay, so all my captains should be here. So be sure that you turn it in by next week. If you happen to have finished in this lab, you're welcome to turn it in now. Otherwise, be sure it's turned in by next week. You're up and running. Good. Okay, so everybody got an individual email from me, right? Right. Okay, now for some of you, it was as simple as like just saying you watched something. Others of you, it was a little longer, more involved. I extended all the due dates till next week because, oh my goodness, yeah. If you can upload through that portal assignment for the Unit 1 packet, go for it. If you can't make that upload, that's fine too. You can bring it in, you know, a hard copy next week. Yes. Yeah, I'll turn it off. So that's the other thing. I'm trying to keep it as cool in here as I can because it gets really warm with all these bodies. We don't have any Bunsen's going, but it gets worse when the Bunsen's going. So for y'all, why do you want to put this in the back of the binder so you don't lose any of it? That's what your mom was asking about this morning. Some of you may have an edition of the textbook that is not the Florida edition. And if that's the case, then it's missing like 4 or 5 chapters in the back that are the ones we're doing now. Funnily enough, their family got both of the copies that I had that were like that, and I didn't know they were like that because whoever turned them into me didn't tell me. So I had no idea. So anyway, if you don't have a book now, or if you don't have those pages, if you go into Student Dropbox, one of the things in the resource file will say Florida edition text. And if you click it, I manually made a PDF of like 190 pages last week to make sure it was there. So you can access it, you can read it. It's all there. Okay. Back what I do have for people, I do have some things. I promised your mom stuff. She keeps giving me jam. So there's more jam. Caitlin. Or cinnamon fig. This one. Use. Y'all be sure when you do Rico that you put your name on the front. So I don't see your name when I'm picking one. More for you. I think you just let that sit now. Oh, and these were from. This is from last year. And this is from last year. Yusuf left early last year and took off for India for like a month and a half or whatever. So he did a lot of stuff early, which is always an option. Remember that, like if you've got something coming up and you aren't going to be here, you can always work ahead. Just tell me what you need. Like we squashed a month's worth of work into 2 weeks for him and he did it. So hooray for you. You did it. All right. So weather and climate, again, this is review. If you did earth science, if you didn't do earth science, maybe some of it's new, maybe some of it's review. And this is all contextual for what are we talking about? If we're talking about physical science, we're on earth. So it kind of matters. Okay, let's see. You can go to the next page now, anytime you want. Forget that. Yes.
It doesn't fit.
Oh, okay. Well, I can I don't think I have a binder clip down here that's big enough for that. I just don't want you to lose it. You know what I do have though? Hold up. Colin, that bin behind you right there on the camera, there should be a little silver ring just kind of floating in the bottom. You see it? Like a
couple at a time.
little clippy
Yeah,
ring.
you gotta put them on a couple at a time. I don't know what go on.
There you go. Just like somewhere in there. I'll hand that to him in case. Yeah, that's all that thank you here. If you want, you can always hook a loop through all of them, so at least they stay together. Okay, so they have a printed copy of the missing pages. That's what that madness over there is. Okay, dokie, let's see. Just to let you know, I did call Teacher Ease last Wednesday. I was on hold for 34 minutes. And when the lady picked up, she sounded just as unable to tell me what's going on as anybody else. She was like, our bug master knows. And I was like, okay, is there any way I can escalate this? Like, I know you won't let me use the paid version. I've asked to use the paid version. If I use the paid version, will that help? They're like, she's like, no, we have paid people that can't do it either. So basically she said she was bumping it up the line. Like, I don't know, escalating to some degree. What I'm going to do, what my plan is for now is obviously Q1 is managed, everything on paper. You can still go into all those assignments though and access all the digital resources. Like if you need a copy of something, or if you have a video as part of an assignment, all that will be accessible through Teacher Ease still. You just can't do quizzes. That's the only thing you really can't do. So anyway, I'm not sure how I'm going to do Unit 2 yet, test. I'm still trying to figure that out. But basically, we don't know. I am going to try to, ooh, there's a pair of my goggles on the floor. I'm going to wait, but actively research other options. If you're wondering why we haven't just jumped to another option, it's because I've been with Teacher Ease now this is my 6th year, which means all the assignments that I spent like hours putting into Teacher Ease are already in it. So from when we did our science last time, I can go transfer that assignment to this year and it just moves it and I don't have to re-enter everything, which, you know, with the right kind of coding could probably be swapped to another website, but another app, but I don't know how to do that kind of coding. And I'm not even I don't even know anybody who does. And it probably costs more than our entire budget. So atmosphere, let's do the atmosphere. Alrighty. So if you know, toss up your hand. So the what, Emily? The atmosphere, that was a really hard one. The atmosphere is the layer of gases surrounding the earth. Your high schoolers mostly, you know this. Forms a protective boundary between earth and space and provides conditions that are suitable for life. So what's it made of? Composition of the atmosphere. It's a mixture of, Drew. All right. And water vapor too. Yeah, nitrogen, oxygen, water vapor are your big ones, and it has everything else, obviously. Carbon dioxide, every other gas is floating around in there to some degree. So some of them are solid, some of them are liquid, and some are, you know, they are also suspended particles as well. In our lower atmosphere, obviously, we have lots of suspended solid particles of everything from pieces of rock to particular molecules that get spewed out when there's smoke or burning. So what is the force exerted by the weight of the column of air on a surface? Oh my gracious. All right, Jordan.
Air pressure.
Here we go. Air pressure. So air pressure is going to, as your altitude goes up, what's going to happen with your pressure and your density, Liam?
It's going to decrease
It's going to decrease. Why?
because there's less air pushing down.
So think of it like a column, right? And think of it like a little person standing on the ground and a little person standing on tippy top of a mountain. There are more molecules in the person on the ground than there are on top of their head if you were to make a column straight up, right? So we measure air pressure using what instrument? Oh boy, Yusuf. What'd you say? You could, oh yeah, or a barometer. That's our kind of go-to. Easy barometer. All right. Anybody keeping an eye on the barometer readings right now? Anybody know? So just so you know, if you go to the top of the our website, at the very tippy top, there's a little thing that says, what's the weather? We have a weather station up on the roof. It reports, so that little screen over there by the window. But yeah, it'll tell you, especially it can be very interesting when we have large events. So I set the levels for alerts. So if there is a wind event or a rain event that I've decided I want to know about, I'd say, you know, if it's more than this much in this much time or whatnot, it will tell me and it'll send me a text actually. But anytime you can go and click and it'll take you to the Weather Underground for that. If you've ever been to Weather Underground, it's kind of like crowdsourcing weather data. And there's more than one station in this neighborhood, but that one's actually labeled as Rico's weather station. So you can see it at any time. What do we expect to happen to our pressure over the next couple days? Anybody want to guess what we should anticipate? I saw a hand back there and it changed. Asher, did you want to guess or?
It'll increase.
You think it'll increase? What do you think? You think it'll decrease because of the hurricane coming? Yeah, that's pretty much what's going on. Idalia, did y'all see Idalia? Okay, so Idalia is passing over Cuba and is now, I don't know what the category is at the moment because it's changing rapidly, but they anticipate maybe Cat 3 when it hits landfall. So it's supposed to kind of go over the western Gulf Coast of Florida, up through southern Georgia and back out. If it gets back out and it cycles correctly for it, it could recycle again, but hopefully not. But keep an eye on it. It's going to be a rainy couple days for sure. Also, the other thing to note, Idalia just happens to be smacking into the coast of Florida right at a full moon. And as you guys know, full moons increase tides. So now they've got real flooding issues. All right, the lowest level of the atmosphere is, all right. Well, okay, well, you got it. Hang on, next one. Yes, that's our troposphere. That's our lowest level. And this is where your weather happens. Okay? All right, yes.
I found a brownie point in the Bible with this A twice without like the 1 and 2 in the.
Oh, okay. All right, I think you guys have found like 4 in the last. That's good. Very good. Okay. All right. So I think we're on 4 then. All righty. What comes after the troposphere, Colin? Stratosphere. Okay. So we've got, making sure I'm sticking them all in. All right. So this is where your ozone is. Your ozone layer is what? Who can describe what is the ozone layer? What's the purpose of it? Do you know, Jordan?
I think it's like a layer of gases that can reflect sunlight and absorb light.
Yeah, in part, absolutely. Anybody else want to add anything about it? What do you want to add, Asher? It what? It blocks some radiation. That's huge right there. Yes, it blocks radiation, which is very important because we already get enough radiation from the sun. We don't need a ton more. Andrew?
I was just gonna say that it's not related to this specifically, but dogs can sense the pressure when the pressure
Yes,
drops,
they can.
especially this one right here who likes to hide in the pantry before anything happens.
Yeah, he doesn't love thunder, and he's learned to. So that's your basic like Pavlovian behavioral modification. It was completely unplanned for him, but he's learned that thunder comes with pressure drops because he notices the pressure drop. We might not, but he does. And then he hears the thunder and that scares him. And now he's like a furry barometer. I mean, if it drops enough, he starts acting weird before the slightest rumble, before there's rain, before anything else he knows. And actually I had a friend post a picture of her beagle on Facebook a couple years ago. Daisy was terrified of storms. And she's like, oh, Daisy, our weather predictor, says it's going to storm. And all it was a picture of the bed and the dog's like butt and hind legs were sticking out. The rest of the dog was under the bed. Oh. So what's our third layer? All right, Bailey. That's our mesosphere. What's meso mean? Middle, right. Perfect, because look, there's 2 on either side. Oh, how perfect there. Mesosphere. And then what's after the mesosphere? Piper. Thermosphere. All right. And then what's the last one on the way out? Milo. It's the, ionosphere or exosphere. Yep, ionosphere or exosphere. Now, if you've been with me before, you know that I love this dude. Okay, this is an earworm. Be prepared. Once you hear it, you'll be singing it all day. But this guy, super help you remember these. I'm telling you, this is a great one.
No.
But you'll be singing it all day. It's like a pirate shanty. And this guy really knows how to do some video editing because it was pretty cool. He sings harmony with himself too. This will be in your head all day right here. Good. There you go. Yeah, my mom lives downstairs, so we can't stop. That makes her nuts. In your head now, in it. Yeah, Caitlin's already mouthing it. There you go. All day, I'm telling you. Got one more. Now he's doing percussion. All right. Yep. Yeah, quite good. Yeah, it is like the Brady Bunch. It's funny, but for real, it's a catchy little tune. It helps you remember. Move on. I said move. Oh no, not you again. Nope. All right, there you go. We saw you won. All right, sun and the seasons. Okay, these are easy review for most of you. So the Earth moves in two ways. What two ways does it move, Ridley? Revolution, rotation, revolution. That's right. What does rotating mean? Bailey. Spins around on its axis. And what does revolution mean? Who hasn't gone? Caitlin, what's revolution? It's not rotating, it's revolving. Caitlin or Chloe? I'm looking at who hasn't, or James. Somebody speak. What's revolution? On the sun. James got it. Okay, yes. So around the sun, yes, that's your revolution. So it rotates and it revolves simultaneously. And then we use latitude lines to mark our regions. Now we have latitude and longitude when we do mapping. What's latitude and what's longitude? Who's going to tell me? Caitlin.
Longitude is this way and latitude.
Yes, and how do you remember that?
Because the ladder.
Because of the ladder, right? So longitude goes north to south, and you can think of it as vertical, like the rungs on a ladder. They are the long part. Latitude runs perpendicular to that, or east to west, and those are like the parts that make those two long poles into a ladder. So there's your latitude and your longitude. So we use latitude to break our planet down into regions based upon how warm and cool they are, which is affected by their latitude. So what is the 2.5 degrees south to, 23.5 degrees south, 23.5 degrees north? Chloe? That's our tropic zone. So that's right around our equator, right? So we're looking here-ish. This has some lines, but not a lot of lines. But if we're doing 23-ish, this is 0, right? Your equator is going to be your 0. And this next chunk up, it says is 10 and then 30. So roughly there to, drop the balloon, here-ish, evenly on both sides. This is your tropic. Your tropics are warmer. Why are they warmer? Ridley. They're closer to the equator. And what about that is going to make them warmer? Colin.
They get light year.
Yes, they're closer to the sun. They're actually, yeah. If you think about it, if the sun's here, the distance from here to here is shorter than it is from here to here, or here to here. And based on the way the Earth tilts, it still stays, the equator still stays pretty level there with the sun. So yes, it's getting more sun or more direct radiation, so it's warmer. So this next set, what's the next region up? All right, go for it, Lucas. No, Lucas, Xander, one of you, sorry, Xander. Temperate, okay, Xander got it. All right, those are our temperate zones. That's kind of moderate. And then lastly is Milo. Polar, okay. Where do we live? Piper? Temperate. We're in a temperate zone. It's nice. All right. So we have seasons, and that's caused by the what? Colin. Tilt to the earth on its axis. And that makes sense because, see, earth is tilted. It's tilted right here. But as it's going around the sun, that the relationship of that tilt to the sun changes, and therefore you get warmer sometimes of the year, warmer sometimes of the year, cooler other times of the year, depending on where you are, nearer, further from the sun. It's not a whole lot nearer or further, but it's enough for us to have seasons. And then as it moves around the sun, what occurs on days when the sun is at 23.5 north, 23, where are we? Chloe. Those are our solstices. Okay. So those are our, the next part, the longest and shortest daylight hours of the year. So what are these? The longest and shortest daylight hours. Emily. Equinoxes. Yeah. We have one in the spring and one in the winter, right? And the one in the winter, is it our longest or our shortest day? Asher. It's our shortest. What do we mean by shortest day? It's kind of a colloquialism. What do we mean by that, Asher?
There is less sunlight, our 24-hour period.
Correct. Yeah. The 24 hours doesn't change, right? It's still 24 hours, at least on our clocks, although that's not there. Those aren't exact. They aren't exact, but definitely there's less sunlight during those days.
I thought the solstices were the longest and shortest day of the year. That's on the.
Oh, sorry, I read equinoxes, but yes, you're right. Solstices are long. It was part of the previous one. You're right. I just read that backwards because I'm like recovering from a week of lack of sleep. Yes, there you are. So yes, your solstices are your equinoxes are the beginning of spring and fall. So yes, there you go. Your solstices are your long and your short, obviously. All right, so rotation and revolution of Earth. There's a quick one on that. Nobody's singing. So that's darn it, right? Some of these intros are so cringy.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it?
Where's it going?
I
No, it's actually that goes somewhere. Because we're on the Earth, and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night, every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night. At the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friends, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning?
Right.
Let's do a demonstration to shed a little light on these concepts.
Like living at the equator, they don't really have much for seasons.
Okay, you're
Weird,
using a
right?
globe and a table lamp without a
So the
shade.
poles too, a
Plus
little
a
bit
table to
weird.
put them both
Mhm.
on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other.
It's not too slow.
It's shining more brightly on the and it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days. And that's another year gone by. So, what does all this show us?
Like her bunny
It
suit.
shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
So if you were at the equator, you don't have much for seasons, right? But the people at the poles, they've got some really interesting situations where they have days of nothing but sunlight and days of nothing but darkness. Uh-huh.
The North Pole have 6 months of sunlight and 6 months of darkness.
Yeah. Can you imagine that? Like even in parts of Alaska, there are towns there where it doesn't get dark for weeks and there doesn't get light for weeks, and you just got to go about your life. And you know, humans and animals and whatnot, we're tuned to that. Like that's part of our natural rhythm, and that can be really bizarre. Drew.
I was gonna say that the earth revolves around the sun, but the sun also revolves around Sagittarius A.
Yeah, there you go. Yeah, we're all basically systems within systems within systems. So yeah. Interesting for sure. Good to keep all of that in mind. And we're going to be talking, like I talked about, is the sun moving? No, the earth's moving. That's a frame of reference. And frame of reference is going to come up in just a few weeks when we hit motion. We start talking about motion, we really get into the physics. Frame of reference is going to definitely be like one of the first topics of discussion, because from our frame of reference, it's the sun that's moving or the moon that's moving, right? By the way, speaking of planets for one more second, did anybody watch the Chinese moonshot last week?
What?
So China sent a craft to the moon, and that was last week, and it was pretty cool. It was very, very cool. So they had the whole thing going live, and it was great because they had a train, not China, I'm sorry, India. It was India. What China? Duh. India. No, my brain died for a minute there. India did it. China's done it before. This was India's first shot where they actually were successful. And it was great because they were translating the whole thing in live time so you could follow what was going on. It was really, really neat. Okay, so solar energy and wind. Okay, so energy in the atmosphere, you get solar energy that reaches Earth, and some is reflected back, some is absorbed by the atmosphere, and some is absorbed by, that's a hard thing to say, some is absorbed by the Earth's surface. So what are the gases in the atmosphere that radiate absorbed energy back to the surface and allow for warmer temperatures on Earth? Xander. Greenhouse gases. Okay, greenhouse effect gases or greenhouse gases. All right, what's the most? There are 2 big ones. What are the 2 big greenhouse gases? Piper?
Carbon dioxide.
Carbon dioxide's one. What's the other? Yusuf?
Water vapor.
Water vapor. Carbon dioxide and water vapor. We did a lot on this last year on Earth Science, if you were here. You'll remember we talked about climate change, what likelihood it is that it's entirely man-made, partly man-made, influenced, not influenced, how much of it's natural. And we watched some documentaries, and we got to see a whole bunch of different opinions. We watched Al Gore, we watched the counter argument to Al Gore, then we watched Al Gore go again, and another counter argument to Al Gore going again. So yeah, it was a good way to analyze data. Lots of data. So without the greenhouse gases, what would our planet be like? Bailey?
Be really, really warm, or, no, we're far enough out, it'd be really cold.
It would be very cold. It would be miserably cold. We could not survive without our greenhouse gases. Now, if we get a buildup of greenhouse gases, we're concerned that then it will get too hot. And that's the argument that is central to the whole man-made climate change discussion, is whether or not we are contributing to adding greenhouse gases that don't belong, that could make us too warm here because we're not letting enough radiation bounce back out. So energy is transferred within the troposphere in 3 ways. Ridley? Radiation, convection, and conduction. Okay. Anybody want to describe radiation and tell me, like, what's radiation, Jordan?
The particles absorb the sun and radiate
Mm-hmm.
heat.
Mm-hmm. So a good example would be if you're standing next to a campfire and you put your hands out like this and you feel the heat coming towards you. Your hand's not in the fire, but you feel the heat, right? That's radiation. Okay, what's convection? Who can give me like an example or an explanation? Colin?
Super hot, so.
Super hot.
You see
Mhm.
the soup closer to the burner will get hot and it'll rise.
Mm-hmm.
And then once it gets to the top, it'll cool down.
Exactly. Got convection anywhere you can see right now? Drew? Lava lamp. See it?
I can't see it.
There's your convection heating right there. Up and down. That's wax, right? So the wax in the lava lamp gets hot when something becomes hot. Well, most things, not everything, but wax. When wax becomes warm, it gets less dense than the liquid it's in, so it floats to the top. When it gets to the top, it's further away from the heat source. It cools, becomes more dense than the liquid it's in, comes back to the bottom and cycles, and that's convection. Drew?
I would say the radiation that comes from the sun is caused by nuclear fusion.
Yeah, that's
You
true.
have lots of hydrogen
Mm-hmm.
compressed by the synapses starved by gravity,
Right.
and there's so much that the atoms go from one hydrogen and then they push together,
Mm-hmm.
turn into a helium.
That's right. That's exactly right. Releases
of
lots of energy. Okay, can somebody explain or give an example of conduction, Yusuf? Yeah, when you touch something and you feel it, that's hot. So when if you were to touch the glass table right now, Caitlin, how do you think it would feel compared to your hand? You can even touch it if you don't have a guess. You think it would feel cold? There you go. Does it feel cold?
Yeah.
Okay, how cold do you think the glass is in comparison to the air around it? Colder, warmer, or the same?
Probably around the same.
It's the same. It's exactly the same. The difference is that glass is a better conductor than air. So when you touch the glass, it better conducts the heat away from your hand into the glass. That's why if you left your hand on there for long enough, you could probably run your hand over the table and feel a warm spot because it's conducting the heat from your hand to the glass because heat moves from warmer to cooler. That's just kind of what happens. Anything else, Jordan, to add?
I remember hearing somewhere that when you touch like steel or some other metal,
Mm-hmm.
it's not cold itself, it just like sucks all the
Yes.
heat out of.
Exactly. It's taking the heat from you. And these are things that are difficult to think about because you tend to think of like, okay, like for example, if I get really, really hot, like sometimes my lupus kicks in and I get super hot and I go and like lay my bare skin against the tile on my bathroom floor. And it's so cold that it's like getting in a pool where you're like, ooh, ooh, like I have to really lay back slowly because it feels super cold to me. But really what it's doing is removing the heat from my body by pulling it into the tile instead of the cool tile pouring into me, right? It always goes hot to cold. All right, so winds, obviously that's the first one. Wind is the flow of air from higher to lower pressure. Okay, so we're getting some lower pressure here. We have a low pressure system moving ahead of this storm, like the storm, the center of that hurricane is low, right? So it's causing wind. When you see a very windy day, it's usually because you got a low pressure system moving in or high pressure moving out, and it causes that wind to move based on the air pressure, either kind of like in front or behind it, if you were looking at it geographically speaking. So you get local breezes, and these blow a short distance, like an ocean or sea breeze. And then you get breezes where land meet a large body of water. Those are good examples of local breezes. So we have a type of breeze where we have cool air over water and they flow onto land. Xander. All right, those are sea breezes. And then what is it when you have cooler air over the land moving onto the water? Yusuf. Those are land breezes. Yep. All right, so it's where it's coming from. So you can think of where it's coming from. Don't try to do that with roads in this whole metro area because it makes no sense. Anybody ever really paid attention to Highway 9? You ever watch that? So if you're leaving Atlanta, when you're in Highway 9, it's called Roswell Road. But when you get to Roswell, it's called Atlanta Street. If you were going north, it makes sense that you're going to Roswell. We'll call it Roswell Road. But then when you get to Roswell, now it's Atlanta Street, I guess. So if you're in Roswell, you know to go the other way to go to Atlanta. And then when you get further, it becomes Alpharetta Highway. Not where it's coming from, right? So where it's coming from is what you're looking for here. So these are global winds, okay? These go long distances in specific directions. And you have convection cells, and these are like global winds. They move in a series of big, huge bands. So a good example of these are trade winds. If you remember from like elementary level social studies, you probably talked about a lot of the great explorers using trade winds to come across the Atlantic towards the Caribbean. And then you got easterlies and westerlies. So what is this curving effect on Earth's rotation that has on all free-flowing objects? James. Coriolis effect. All right, if you want to mess with somebody, there are some fabulous videos online of people trying to show that Coriolis effect is affecting like a whirlpool of draining water, and they stand there at the equator in Ecuador and they do this fabulous thing where they have like a basin of water and a little flower, and they drop it in and you watch it go one way and then you go the other side and you watch it go the other way. Really, it just has to do with where they punch the hole in the basin. But a lot of people are like super excited to see it. Oh, look, it goes the other way on the other side. So really not so much. So those are our Coriolis effect. And you can, we did it last year, I think, with a globe, but you can do it with a balloon too. If somebody stands underneath and like holds a marker still and you turn the balloon, you can watch how it kind of makes this bend or this curve. All right, so what's the wind system that's characterized by seasonal reversal of direction? Ridley. There you go, monsoons. We don't have monsoons so much here as an issue, but where might you find a monsoon? Where's a place where you might find one? Yusuf? Where? Where is that? Ah, they get monsoons? How about in the U.S.? Anywhere in the U.S. get them? Asher?
Florida.
Florida, low for sure. What were you thinking? California, a lot in the, what were you going to say, Lucas? Hawaii, yeah. So maybe a little bit. A lot of our monsoons come right in our desert region. We get a lot of monsoons. I have a friend that lives in Albuquerque, and she has a bridge to enter her house. Like her driveway has a bridge built in, and underneath of it just looks like a little valley of rock. And it's like, why didn't you just cover the rock up? Because certain times of the year, that's not rock. It's water for a long time. So there has to be a bridge. All right, so then what is this high-speed belt of wind, the upper troposphere? Caitlin?
Jet stream.
That's our jet stream. This is why if you are traveling east to west in a jet, is it going to take you longer or a shorter amount of time? How about this? If you're going west to east, is it faster? Or if you're going east to west, is it faster? Takes less energy for the jet. Kind of depends where. What were you going to say, James? Yeah, west to east. What about west to east? It's faster west to east because the jet stream moves that direction. And if you're in a plane that can take advantage of the jet stream, you can move a little more quickly, use a little less fuel. It's a little more efficient. Whereas the other way, you're going against it. It's like swimming upstream.
But if you're not using the jet stream, it would actually be faster to fly east to west, going against the Earth's rotation.
There you go. Yeah, if you're thinking about it in that sense, absolutely true. Yep. So yeah, if you've ever done that, where you've taken a flight one way to, if you've ever gone across country and back, you can definitely experience that. That's true. All right, so water in the atmosphere. Water is everywhere, especially here. So humidity. The amount of water vapor in the air is humidity, right? Okay, so this next one. Ratio of the amount of water in air to the amount of water the air can hold. All right, Jordan?
Relative humidity.
That's our relative humidity. It's relative because it's relating how much it can hold to how much there is. And what's the temperature at which air becomes saturated? All right, Lucas.
It's not on that, I'm kind of brownie point.
Oh,
It says, if instead of saying ratio, it says ration.
yeah, I think that was already caught, but yes, that's a good one. It didn't catch it. Spell check didn't catch it because ration is a word, but yeah. Uh-huh. Dew point, right? This is where your temperature is, the air is so saturated at that temperature that you start to see dew, frost, clouds, fog. And that usually is it going to be at a cooler temperature or a warmer temperature? Warmer? Anybody else have anything? Piper?
Cool.
Why do you say cooler versus why do you say warmer? All right, Asher, you give us your reasoning, and then Piper, you give us yours.
There is more friction in the air, which generates heat.
Mhm.
Because of things moving through the air.
Okay. Good one. What were you gonna say?
Because cold air can't hold as much water?
There you go. Okay, yeah. So what were you gonna add?
And water condenses when it gets cold.
Right. So basically, if you wake up in the morning and there's dew on the grass, what happened is you got a drop in temperature overnight, but the humidity was high or high enough that the water in the air started to condense because at that temperature, it can't hold it anymore. When the air is warmer, it can hold more water. And then, yes, the particles will move around, obviously, and then you'll get warmer and warmer. But yeah, overnight, that's why you get dew. So then your dense visible mass of tiny water droplet size. This is an AZ1. Chloe, that's a cloud. We have all kinds of different clouds, right? So clouds form as warm, moist air rises, water vapor condenses in the atmosphere. And it's weird to me sometimes when you look at them, sometimes they look really solid. You know what I mean? Sometimes they really do. They're super opaque. They look really solid. And you're like, oh, you know, that's something you could touch. They really look like cotton, but it's water and it's weird. It's really weird. Sometimes you look at it and you're like, oh, it's definitely water. So we have different types of clouds. So our three basic cloud forms are stratus, cumulus, and cirrus. So what are the flat ones that cover most of the visible sky? Emily. Okay, those are our stratus ones. That's when you look out, it's kind of stratusy right about now, actually. Really don't see the sun, just kind of see a white, grayish white sky. So the puffy ones with the flat bottoms, these are, Jordan? In the binder?
In the binder, it says status.
Oh, does it? You caught another one. Okay, there you go. Y'all are catching a lot. Yeah. You can tell how quickly I had to scramble some of these things together. Caitlin? Yeah, these are the cumulus. And the ones with the flat bottoms are the cumulostratus and cumulus. These are the ones that like, these are the cotton ball ones. These are the ones when you draw a picture in kindergarten, and you make the little clouds, right? That's what these are. So what are the white, whispery, feathery ones, Yusuf? Cirrus clouds, that's right. And then these last ones, when it's on the ground, we call it, Piper?
Fog.
That's fog. Yep. When you get the cloud on the ground, it's fog. If you ever go driving someplace where it's a lot of mountains and valleys, sometimes you'll drive in and out of the low-lying fog. Y'all with me? But you'll drive in and out of the fog based on your exact elevation. If you're driving one of these roads like this, in and out and in and out, and that's really kind of a neat thing. You don't realize you're in it till you're in it. And then you go back down a hill and it's clear, and then you come back up and there it is again because it's laying at a certain level, or it can be lower and you can go above it and below it. So our most common types of precipitation are rain, snow, hail, sleet, freezing rain. Okay, think about how each of these falls. Obviously, it's gravity causing it in every case, but why does a raindrop fall straight down and a hailstone fall straight down when snow kind of floats? What's the difference? Ridley, what you think? Okay. Yeah, it's that in part. So what you got is it's partly density, and it's also partly surface area. So this would be a good representation of snow. And if I drop it, it's gonna float, right? Because it keeps catching the air. But if I ball it up and it becomes rain or hail, it's just gonna go straight down, right? It's the same it's being pulled by the same force, but the force is acting on it differently based on how much of the surface is being acted upon. So if you get, more of a float as opposed to being crunched up. So you get snow versus rain that way. How does hail form? Ooh. All right, Lucas.
Water condenses.
That's partly it, part of it. Part one, step one. Asher?
When it's essentially snow, but it gets pushed back up by a cold draft.
Mhm.
Which one actually freezes it, and then it comes down because the
Right.
air cannot.
Yeah, so it's kind of like you're dealing with rain, and it usually hail happens in warm weather. So because you have an updraft, because you've got a lot of warm air, cold air is going to displace it and come underneath. Now that's something to keep in mind in this class in particular, because we're talking about physical science. Warm air does not rise. It is pushed up by denser cold air that displaces it and goes underneath of it. Same thing with warm water. These guys in here, they appear to be rising, right? These bubbles of blobs of wax, they're not so much rising. They're not rising of their own power. They can't do that, right? It's that they're less dense than what's around them. And the denser material, the fluid they're in, is displacing them. And as it pushes down, they're forced upward. So they aren't rising of their own volition. They're being forced upward. Same thing happens with an updraft of air. So you've got a storm usually in the summer in particular, and you'll get raindrops that are coming down but getting forced back up, and it's much colder up here. So as it comes down and gets forced up, it freezes, comes back down and gets forced up, and another layer freezes. And if you take a nice bandsaw or something of that effect, or some kind of tool similarly, and you slice a hailstone in half, you can see the layers. It's like an everlasting gobstopper. You can see all the layers in it where it's gone up and frozen again and gone up and frozen again and added a layer. And you can have, when we get hail here, it's usually little, but it can get softball size. Yeah, and that's bad news. You do not want softball size hail, softball size hail. I can't speak. Anywhere near you is what I was going to say, because it's super dangerous. Even the little hail causes damage to vehicles, roofs, all sorts of things.
I think I found a brownie point. It says ration of the amount of water.
Yeah, Xander caught that a minute ago. Or one of you guys, Lucas. Which one of you caught it? Lucas caught it. Okay. All right. So humidity. This is just living in the South, basically.
Ooh.
Is it bad? Let's go.
So if you've lived here for more than a season, you know what it's like. That actually happened to me yesterday with my sunglasses. I walked out of the house and it was they were cold because they'd been in here in the AC. And when I walked out into the yard, they fogged over so quickly. What was it? Was it something terrible? Oh, I don't even know. The things YouTube suggests, it's like, what are we doing? Like, I'm very careful to, like, when I'm searching for videos, to make sure that I'm under the Lab Rats account and not my own, because I admit, like, I love this dude who takes care of cow hooves. Anybody ever watch the Hoof GP? Okay, people really like Dr. Pimple Popper. That's a thing, right? Let's all admit it. There's a weird human psychology. She wouldn't have a successful YouTube channel if people didn't like it. The hoof guy fixes cow hooves, which I didn't even know was the thing that needed to be done because I didn't grow up on a farm, but their feet get injured. They get like nails and stuff in their feet. And this dude, like, he uses these knives and he like shaves their hooves down. But there's some grossness in it because sometimes there's like abscesses in there, and I don't want that in your slideshow. So I'm always sure I'm on the right account when I'm looking at videos, and still weird crap gets in. So who knows? YouTube is bizarre and suggests weird things. So weather patterns, air masses. So air masses form when you get a large body of air that becomes fairly stationary over a region of Earth's surface, or as air moves over a large uniform region like the ocean. So then you have fronts. So fronts are these sharply defined boundaries that form when two air masses meet. So we've got four types. There's cold, warm, stationary, and occluded. So when you have a cold mass take over a warm mass, that one is, Caitlin?
cold front.
That's your cold front. Okay, when you have a warm mass take over a cold one, Chloe, that's your warm front. Okay, what happens when neither takes over the other, Colin?
Stationary.
That's stationary. And then what happens when you get this warm air stuck between two cold ones, Emily? That's occluded. All right. So what we're watching now with the weather is we're watching Adelia come in, and obviously she's got lower pressure, but she's warm because she's picking up water from the Gulf of Mexico, and it's nice and warm down there this time of year. That's why this time of year is when we see the hurricanes, right? The water's really, really warm, and as those air masses move across the equator, they pick up more and more water, and then you start seeing the rotation and whatnot. Did you find another one in there, or is it the same one?
It's the cloud form.
Oh, that'd be down
Status.
Yeah, they got that one. Yep. All right, so here we are with low and high pressure again. We talked about low and high pressure air. Now it affects air masses and weather patterns. So what's the weather system with the center of low pressure? Piper. That's a cyclone. That's right. And they're associated with clouds, precipitation, stormy weather. Cyclones, like hurricanes and stuff fall within this category. And do you guys know that, like, in the Pacific Ocean, they're called one thing, and in the Atlantic Ocean, they're called another? So we know what they're called in the Atlantic because we're dealing with it. What are they called in the Pacific, James? Typhoons. Yep. All right. Oops, sorry, I didn't mean to hit that. Anticyclones. Anyway, that's your high pressure at the center. So your weather associated with your anticyclones are clear skies, very little precip, generally calm conditions.
I think I got another value point.
What is it?
In the high pressure and low pressure, it goes 1A, 2B.
Mm,
Instead of
2B.
2A.
Oh, okay. All right. Y'all are finding lots of those little ones. Those are all like the auto formatting that sometimes I don't notice because it does it on its own.
And then
Oh, another?
one in tornadoes, it goes to 1 instead of 2A.
2-1 instead of 2A. Okay. All right. There. And we're not under another 2. I'll double check it and make sure that it's not under an A and then down to 2 and then down to 2-1. All right. So thunderstorms. All right. This is when you have columns of air rise and your cumulonimbus cloud. All right. Your cumulonimbus cloud, that's the one with the big old flat bottom and it's gray. People call them thunder bumpers, thunder clappers, thunder heads, all kinds of fun names for them. So what is your sudden electrical discharge in the atmosphere? Oh, who do I pick? Emily. That's your lightning. Okay. There you go. There you go. All right, McQueen. Yeah. Good job. And then what is produced by the rapidly expanding air along the column of lightning? Liam. There you go. Your thunder. All right. So when the lightning is moving, you have this column of charged particles, right? And it causes such a rapid expansion and contraction of the air around it that it does produce the sound. It produces waves that produce a sound. So that's what you're hearing. And it's obviously, you've got all kind of different thunder. You've got the thunder that's the rolling thunder. Everybody, oh, that's kind of nice. You can nap through that, right? And then you have the one that actually makes you jump because you're minding your own business and it's just like bang all of a sudden. Those are fun. Yeah.
It happens to me when it storms because I'm closer to the attic than everyone else.
Oh yeah, really loud up where you are.
I got lots of cool
Did you?
It was all sky lightning.
Oh
And
neat.
it was like, they were very visible.
Oh, they were going horizontally too. I saw them. Yeah,
It was really.
was
pretty.
quite
so
lovely.
So yesterday I was at my ice practice
Mm-hmm.
and there was a thunderstorm happening outside and it got so humid outside.
Mm-hmm.
Now there like fog was coming off of the ice.
Oh yeah, I believe
The
it.
lights were like flickering.
That's crazy. Yeah, there were some big storms. And if you guys pay attention over the next couple days, there's going to be some really interesting weather. If you like weather, like thunderstorms are my favorite weather. I really like them. They don't scare me at all. I really enjoy them. Like if it starts thunderstorming, I make sure all my blinds are open and I'll sit here and I'll watch because I love to watch the trees bending and
Yeah.
I just think it's cool. And if you go down to my mom's, the deck is has a ceiling from her level, so you can stand out there and watch it go around, but you can't see as far. We're on the top of a hill right here, so if you stand, especially if you go all the way upstairs, but if you stand on the deck, you can see way down into like Fulton, so you can really see some of the lightning moving and whatnot. So tornadoes, these are not big compared to other weather systems, but if you're on the ground and one's coming, I don't think you really care how big it is. It's still a tornado. So obviously you know what that answer is. So they're small, intense windstorms, and they take the form of this rotating column of air. Anybody ever seen water spouts? You ever seen a water spout? What's a water spout? Do you know, James? Yeah, if they occur over the lake or over the ocean, and it's like a little mini tornado, and it spins around and it pulls the water up, and you can see these they're like little tiny twisters. And then you've got what do they call those, dirt devils or whatever, in parts of Australia and out in the desert, where basically you get the same thing at ground level with dust and dirt. So tornadoes form when you get a vertical cylinder of rotating air, and usually it develops within or around a thunderstorm. Tropical storms and hurricanes. Here's where we are right now. Large tropical storm, winds of at least 199 kilometers per hour. It goes from being a tropical storm to a hurricane. Now, get your phones out if you have them. We're gonna guess. This should be entertaining. So if you've got your phone, go ahead, grab it. I'll give everybody a minute.
I found the brownie point.
Huh.
It says the chapter title, but it doesn't say chapter.
This says the what? The chapter title, but what?
Chapter number. Yeah.
But it says it at the beginning, right?
See, like there. It says have the.
Right, that's okay.
Yeah, but it doesn't have- What was number? So why is it one? Yeah.
Oh, yeah, that would be simple. But you know where you are because it's at the beginning right here. Tells you.
It doesn't, usually at the end it's just like two.
Yeah, sometimes it does. Yeah, sometimes it does. You're right. That one doesn't leave it out.
Miss Danny, what's the Wi-Fi password?
Okay, Wi-Fi password is right here on the front.
Oh.
Rico, with capital letters both. 1, 2, 3, 4. Sorry.
found a brownie points from homework.
Oh yeah, I'm not surprised. The homework got cranked out in 48 hours.
Sheet that tells you what you need to do.
Oh, not surprising. Literally cranked out in 48 hours. Like, that was ridiculous.
Yes.
All right, does everybody have it up?
I
We're
don't
getting
have
there?
it yet.
Don't have it yet? Okay, take a second. It probably won't show you anything yet until I click, yep, it should say right. What now?
It's an important from the beach. What
Yeah,
is it?
you'll see in a second. Yep. All right, we got it. Wait for Jordan to get it. I think everybody else has it or as close to has it. All right, so here we go. So reporting from the beach. This is don't mess with Mother Nature. Reporters in extreme weather. You guys are going to guess what's about to happen to the reporter. And here's how you're going to guess. You get to write a word. Okay, you'll get to type in a word and it's going to show up in a word cloud. So be sure that whatever word you're typing in is appropriate. And sometimes your guess might be more than like a word, like you could describe the situation. So do your best to condense it. Huh.
Funny thing about reporters in extreme weather, when you see the reporters on the news during a hurricane, they're on the beach and the wind is crazy and all that.
Yep.
The thing is, if you go just like a mile inland, there's no wind.
Yeah.
They intentionally make it look worse than it is.
Yeah. My returning students know this, but I grew up in Virginia Beach. I'm Virginia Beach born and bred, so I know my hurricanes and I know my weather idiots on the beach. So this first one is actually local to my hometown. So what will happen? I'll let you guys start your guessing. I'll give you just a minute to guess what's about to happen. What's going to happen in this scene? Bad hair, water spout, something. Duh. What's going to happen? Throw out a guess. Here we go. Here they come. He gonna drown. I like that. He gonna drain by. He just might. Soaked, fall down deaf. Ah, all right. This is good times.
Oh, this is great.
They can show the title of the video
Mhm.
right
Yeah, they could. So here we go. What's gonna happen?
I didn't do it in time.
Beach and ocean view is now non-existent. There is no sand. It's hitting.
Style on the beach. All right. These are what you call townies. All right. Yeah, that's Wavy TV 10. So that's local to Hampton Roads, Tidewater. That's my local growing up station. And That part of town is Ocean View, which is not actually 10, 20 years ago. You did not want to be in Ocean View. It was not a good part of town. Now it's much nicer, but it was a little scary for a bit. Oh, yeah, yeah. All right, now here's another one. All right, walking in the wind. What's about to happen? Duh.
He died.
Blown over. There you go. Concussion. I like it. It's a very good guess.
Oh my god.
Fallen and can't get up. He needs a button to push. My goodness, this poor dude.
He don't fall.
He died. Shit.
Blown over. Fallen and can't get up. There's another.
Tub and hip fracture.
Tub and fit. There you go. Tip fit fractures. All right. Well, what happens when you try to walk? And oh, there's another talking. 109 miles per hour. Yeah, I love these guys. They try real hard.
After the first one, we
Watch the video out of New Hampshire. If you've ever wondered what it's like to walk. Again, wind, favorite butter. The Mount Washington Observatory shares this video of a researcher. You know, it says struggling to stand. The researcher is having fun. I have to believe. The winds actually peaked at 109 miles per hour earlier this week.
God bless him. He was having a good time.
yes.
All right. You may have seen this one. What's about to happen? Reporting in the storm. It's probably familiar.
I've seen this.
Yeah. This is why you don't mess with Mother Nature. Yeah. Christine, stop it. Every meme ever. Yep. Yep. Oh, that's a good one. Yeah, pretty much. Oh boy. Bless her heart.
Don't make unnecessary journeys. Don't take risks on treacherous roads. And don't swim in the sea. Incredibly, people have been spotted in the water here in Black Rock and Salt Hill, both today and yesterday.
Yeah, should have been the next one. All righty. And our last one. This is reporting from a flooded street. What's about to happen? I've already showed you the dot, but yeah. Death by water. Last, yeah, but you still don't know exactly. Yeah. My favorite one of these is actually on. Yeah, there you go. Actually, at the ocean front in Virginia Beach, and they for real they streaked. They didn't just video bomb, they streaked. They like dropped their trunks and ran naked through the screen. And the reporter was like, oh, and they're like running around naked because it's like, those are probably people I went to high school with and they just don't, that's probably them. So, yep, here we go. These dudes. Gotta love them.
Brief lull, but one of the first in a long time, but now the wind's kicking back up again. Ken Myers from nearby, I've seen it, and
That's something I.
it said that, oh, there we go. There's some of the hooligans having some fun out there. I'll say the mayor would not be.
As serious as this is, right, we've always got to expect something like this at some point. Okay, they're giving us a little humor, but all right, could get a lot worse. Those guys will not be out dancing in the water if indeed it does.
Oh yeah, they will.
Gotta love it.
They probably.
Yeah, where I grew up, it's like they don't take the hurricanes that seriously because it's gotten worse, but you guys know, you've seen how the media like gets super excited about snowstorms. Like they make a deal out of it for days and it's like, we're all gonna die and freeze to death. And then like nothing happens and people post social media photos of their little lawn chair tipped over and a little frost, and they're like, we will rebuild, you know, that kind of business. But like growing up in a beach town, for real, people, it's gotten worse. Like it didn't even used to be that bad, and they still don't take it seriously because like Gangnam Style on the beach, whatever. They're like, go ahead, sure. My grandfather was one of those people. He lived 4 blocks off the ocean and never evacuated. Even when the really big ones like Gloria in the 80s and whatnot came through, that man refused to leave. And if we had to go get him later, the oceanfront streets flood. Actually, yesterday was the first day of school in Virginia Beach, and half the streets were flooded just because they're street level. It is sea level streets. There's nowhere there's no flow because there's no slope anywhere. So we're talking like you can't drive water like this in the streets. So fun times. Yeah.
Can you play the stop sign one time?
I'll play it at the end of class if we still have time. So predicting weather. You know, Jim Cantori's the Weather Channel guy, and they say
Unreliable.
yeah, they say if he shows up, you should just leave. but I've, like you say, surprisingly unreliable. I've seen him show up all kinds of places. So predicting weather. All right, so weather forecasting. What do we call the scientists who study the atmosphere? Chloe, these are our meteorologists. That's right. And they use lots of different technology, lots of different tools to help predict weather, including Doppler, automated weather stations, weather satellites, high-speed computers. If you go to the Weather Channel, you go in the app or you go to the website right now, they actually have a really interesting video where they talk about different models showing a different path for Idalia coming through. And they show, instead of usually when they show like a path of a storm, they show like this broad kind of area where it's sort of transparent. You can see it, but it's a different color, you know, translucent. Anyway, this one had actual lines, and the lines are all different colors, and every one of those is a different weather model. There are all kinds of weather models. And when it comes to be winter season, if you get into any of the, like if you start searching on social media for the guys like the local weather predictors, the ones that aren't working for the news station, but the hobby weather predictors, they will downright argue over which model is the best model. Like weather nerds get very serious about their weather models. No, you need the European. No, you need the whatever. And so usually if you're trying to make a prediction, you combine data from all the different models and then decide based on that what you're going to put out to the public. So you have different things on weather maps, and they can show predicted temperatures, sun or cloud cover. You can see little symbols, all that good stuff. They've got rain or snow to show areas of precipitation. So what's the line on the weather map that connects the areas of equal temperature? Bailey? Isotherm. Same therm temperature. And then what do you call the one where they're showing areas of equal pressure? Oh, Caitlin. Isobar. Yes, we use our barometer to check pressure. There's your isobar. Perfect. This one is amazing. Love this dude. This guy is in Malawi, and he's giving a weather prediction in Malawi. And I don't know who he is and if this is his normal shtick, but if it is, I would watch the local weather every day because it's worth it.
A lot of rain will be pouring down. And when it is pouring down, it is going to be flooding into peoples of Malawian bodies. And people with the water will evaporate when the heat has come down. Once the water has evaporated, it goes up in the sky. When it goes up in the sky, the water will condense again. Then what?
Then what? He's like explaining kindergarten water cycle, but
to be the
he's
weather
a lot of
prediction station.
he's so excited about it, and I love how passionate he is about the weather. Yeah, he goes up, and the people, I don't know about the booga booga booga, I don't know that. All right, so climate. All right, climate and weather are not the same. Climate describes what? What's climate describe? You said. Like, be more specific. Piper? Oh, okay, Caitlin.
like the 30-year weather.
Yeah, it is a
versus
30, you remember,
day-to-day.
30 years. Yeah, it's a 30-year average. So it's a long-term average, and the long term happens to be 30 years. So it's a 30-year average. Good that you remember 30 years. So it's going to include things like your annual variations, and some years are rainier, some years are not as rainy, some years are drier. Interestingly, this is a side tangent, but I love this one. Who knows what a Stradivarius is? You ever heard of a Stradivarius?
Sounds like the Zodiacs.
It does, but it's not. It's actually a particular brand of violin, and it's the most highly prized brand of violin in the world for all time. A Stradivarius violin is like top notch, and they're exceedingly expensive.
It's like that very specific wood.
It's yes. So they did recently, in the last decade or whatever, scientists are like, okay, why are these so amazing? And the reason they're prized isn't because they're prettier or something. It's because the sound they produce is so much better than your run-of-the-mill violin. So they did some tests trying to figure out, why are these things so incredible? Why is it making this sound? Well, it turns out the wood for Stradivarius violins all come from the same forest. So they went in and did research on the forest. These are old growth trees. They were able to determine, based on the tree rings, what the patterns for growth had been in particular years, which is largely based on precipitation. And they were able to determine that the ratio between the rings of different years of growth was such that it allowed the vibrations from the strings when the bow hits them to travel through the wood, and they move at a particular rate, and it doesn't get chopped up as much as it does in some other from other trees, I guess. But that's what it came down to. It came down to weather over time, climate in a particular area, and then specific weather over time, that created the most expensive instruments in the world. And we're talking, some of them are like hundreds of thousands, tens of thousands. These are like really high end. They're really cool. If you listen, like if you look it up, you can hear videos of people, playing a Stradivarius versus your, Walmart brand violin. And it's like, oh, I mean, even if you're not a musician, you can hear the difference. It's interesting. They're much more resonant, and the timbre is more pure. It's pretty cool. So what causes climate? So latitude. All right, again, this is our east-west, and we talked about this just when we pulled the globe out and looked up and down the globe. So got different amounts of solar radiation. The other things that are involved, topographic effects. So climate at the top of Mount Everest is not the same as the climate at the base, clearly. And the top of Mount Everest is not going to really change elevation. So that's a topographic effect. Topographic meaning changes in elevation, whether it's mountain, valley, whatnot. And then temperature generally decreases with altitude. So think about top of Mount Everest is nice and icy, right? And it's much cooler up there than it's going to be down at sea level. So then what do you think this next one is? Distinct regions of origin caused primarily by differences in the amount of solar radiation. Do we know? So air masses again, there we are again. Your air mass is designated or named based on what? Who remembers? This is last year. Does anybody remember how we categorize an air mass? It's based on where it forms, right? Where it forms, that's what we care about. So if they form over land or water, what latitude they form at, all of that has an impact on the type of air mass you're dealing with. And then they affect average weather conditions. But if you have a topography and global wind patterns such that you always have particular type of air mass visiting the same area again and again and again and again, that's obviously going to be less, weather, of course, but it's going to be a contributor to the climate in that particular area. All right, this is our dude, our most recent science dude.
Okay, so we scientists were so good at making these dire long-term predictions about the climate. How come we're so lousy about predicting the weather? Besides, this year, we had a colder winter in my town. For all the scientists, though, we could be in for global cooling. Here's the difference between weather and climate. Weather is what the atmosphere does in the short term, hour to hour, day to day. Weather is chaotic, which means that even a microscopic disturbance can lead to large-scale changes. That's why those 10-day weather forecasts are useless. A butterfly flaps its wings in Bali, and 6 weeks later, your outdoor wedding in Maine is ruined. Climate is the long-term average of the weather over a number of years, is shaped by global forces that alter the energy balance in the atmosphere, such as changes in the sun, tilt of the Earth's axis, the amount of sunlight the Earth reflects back to space, and the concentration of greenhouse gases in the air. The change in any of it affects the climate in ways that are broadly predictable. My friend meandering represents the short-term fluctuations. That's weather. It's almost impossible to predict what will attract his interest next. It's not hard to know what the range of his meandering will be, because I'm holding him on a leash. We can't observe climate directly. All we see is the weather. The average weather over the course of years reveals a pattern. I represent that long-term trend, which is climate. Here I'm the man, not the dog.
I want to watch the dog.
My friend here. So climate is predictable. Climate has changed many times in the long history of the Earth, but always in response to a global force. The strongest force driving climate change right now is the increase in CO2 from the burning of fossil fuels, which is trapping more heat from the sun. All that additional energy has to go somewhere. Some of it warms the air. Most of it ends up in the oceans. All over the world, the oceans are getting warmer.
So that's, who's that? Who knows? Neil deGrasse Tyson. That's right. All right. So who remembers the counter argument? What was the last thing he just said? The oceans are what? Getting warmer. Okay. So what's the counter argument to what he said is the cause for climate change? Who remembers? We went over this last year, so we knew both arguments. All right. Chloe, what do you say? Oh, hang on. Drew's making eyes this loud. Okay, go ahead.
Increased solar activity and
Yeah, you're getting, yep, that's right. Increased solar activity. And then Bailey, what else? Clouds. And what else, Yusuf?
Well, you know, the water vapor is very less compared to the other gases.
That's right. Okay, water vapor is the biggest contributing factor to greenhouse effect and climate change. However, the big point to remember for the counter argument for this, the argument that the pro man-made argument is we are burning fossil fuels. That's putting more carbon dioxide into the atmosphere. That's making more of a greenhouse effect. Therefore, we're trapping more solar radiation and the oceans are getting warmer. The counter argument is there are solar flares, and solar flares send more radiation to the earth. And as that radiation heats the oceans, gas is more soluble in colder liquid. So as the ocean heats up, less gas can dissolve in it. Therefore, there is more carbon dioxide in the atmosphere. So one argument is we're putting carbon dioxide in the atmosphere and that's making everything warmer. The other is the sun's making the ocean hotter and the ocean is absorbing less of the carbon dioxide from the atmosphere and that's making everything warmer.
I think both.
It could very well be a combination of both. But when you hear those arguments, always listen, remembering that what's the thing I always say about science and being settled? It's never, ever settled. Who remembers why? We got 3 points. Who can give me 1 point? Piper.
It assumes science is in a binary state.
Right. It assumes science is in a binary state. It's either settled or unsettled. Bailey?
Natural science isn't about 100% true, so like,
Yep.
it's always changing.
Narrowing uncertainty is the other one. Natural science is not about 100% proofs. It's about narrowing uncertainty. Formal sciences, logic, math, that's your absolute proofs. And Colin, do you know the third one?
Everything you think you know could be proven wrong one day.
That's part of the binary one. Does anybody remember the others? There's 3. Do you remember?
A good explanation in one
Yes.
something.
You're there. Okay, this is the one that's hardest to remember. That a good understanding in one area of science does not negate your level of understanding in another. So say we really understand this part of climate, but this part we don't know as much about. Just because you know a lot here doesn't mean you know an equal amount here. And if you know a little here, it doesn't mean you only know a little here. We know a different amount about different topics. There's more we understand about some things than about others. So knowledge in one area of science does not necessarily negate good understanding in another area, or vice versa. Those are the three. Those will be on every exam you ever get from me. So be sure that you get those three in your head. Okay, so that's the end of this. Before you tick up, so you guys have like a week left to get in everything. Want you to know, I see the emails when they come in, but I'm not always like right here at home when I see them. So I usually don't respond immediately. And I do that on purpose, because if I respond and say, I see, like if you say, hey, I watched the video, and I respond to you and say, okay, I will then forget to credit you because I don't see that as an unopened email. Now it's gone, forget it. I took care of it. Oh, nope. And I don't remember to credit you. So if it's something you need immediately, like I'm missing this, or I've looked everywhere and I can't find this, obviously ask your classmates first. That's a good step. But if they don't have the answer and you need something from me immediately, a text is the way to get it. Because a text, if I'm in the middle of something and I can't answer immediately, I leave it there, and I know I check my text more regularly than my email, and I respond to them faster. Okay, so if there's something you need that's a question and you need it resolved immediately, text it. And you can text anytime. My phone turns itself off at like 11 o'clock. It does the little thing where it lets me sleep. So if you text me 3 times in a row, like you hit enter, 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 then it's going to wake me up, because it goes, oh, there's a problem. Somebody needs you. But if you're not one of those people that types a sentence and hits enter and types a sentence and hits enter, it's fine. I won't see it till morning. It's not going to wake me up. All right. So you can do that anytime that you have a question. If it's, I'm turning in an assignment, just email it. And usually by Wednesday, I have all of those grades entered. And then if you don't see it, be like, hey, did you get my email? Then I'll look. Okay. I got like 30 emails in the last week and probably 60 the week before. So I'm getting through. It's been fun. Any questions about anything today? Nope. Yes.
Can you play the stop sign thing?
I'll put the stop sign back on. Yes. And I'm gonna put these over on the counter where you guys can get to them better. And you can enjoy. She was so passionate. And then it's like, oh, yeah, she was uber passionate for somebody who was getting slapped in the face. You know,
Did you see my email?
you learn the hard way. Probably was it one of them?
I sent
That's what I was just saying. I see a lot of them, but I don't respond immediately. It's too much. If you have something to, is that to turn it? Okay, up there in the folder, there's a folder up there. Do you see it? On the chest, there's some folders. Yes, anything you have to turn in can go in the folder over there.
Have like the first lab thing in
Perfect.
here, 'cause I didn't know if you
That's
wanted to
perfect
do
too.
that or
Yep,
not.
you can do that too. Just be sure your name is on it. Always be sure your name is on it. Because otherwise, I don't know who you are. Not that good at handwriting yet. Really depends. Lady. Oh, come on, lady. I need to see your. I need to hit that first. Do your thing, lady. Fine, I'll do it this way.
Okay.
Don't make unnecessary journeys.
So passionate.
Don't take risks on treacherous roads. And don't swim in the sea. Incredibly, people have been spotted in the water here in Black Rock and Salt Hill both today and yesterday.
So terrible.
I said, Christine, stop it. What I meant to say was just stop it, but apparently it just decided to autocorrect just to Christine.
I like
Don't know
it though.
how.
That's good. It works.